A Brief History of a Perfect Future. Inventing the Future We Can Proudly Leave Our Kids by 2050. Written by Chunka Moy, Paul B. Carroll, and Tim Andrews. Narrated by Stephanie Dillard. Dedication. From Chunka, Paul, and Tim to our kids Zoe, Kai, Claire, Shannon, Tyler, and Brett. And of course, to their moms, Beth, Kim, and Valerie. To our kids' kids, and to theirs, on down the line. To your kids. Introduction. Inventing the Future. When Xerox CEO C. Peter McCullough established the Palo Alto Research Center, PARC, in 1970, Xerox executives were, naturally, curious to know what their corporate crystal ball would tell them about the future of computing. When Alan Kay, a team leader at PARC, was asked for the umpteenth time to say what the future would hold, he snapped there was no easy way to know. The best way to predict the future is to invent it, he said. That line became a mantra for Alan and for PARC, which did unbelievable amounts to invent the future by laying the foundation of today's computing experience. It also became a mantra for the three of us, as we worked with Alan for decades, and it drives the narrative of this book. In the following pages, we'll lay out ways that we, as a society, can harness the technological marvels at our disposal and invent a sparkling future. At PARC, starting in 1971, the mantra played out over 5 glorious years as researchers invented many of the core elements of information technology. Alan's team contributed to the development of the first personal computer and gave it the overlapping windows and graphical user interface that Steve Jobs copied for the first Apple Macintosh. Alan invented, with Dan Ingalls, what today would be called dynamic object-oriented programming, which is a big reason you have so many apps on your smartphone. Developers can easily incorporate software objects others have already written, rather than having to write all the code from scratch. Other teams at PARC developed desktop publishing, the laser printer, peer-to-peer and client-server computing, and Ethernet, which enabled corporate networks of personal computers. And, while PARC didn't invent the Internet, its researchers made such significant advancements that PARC deserves considerable credit for it. A half-century later, most of the information technology industry and much of global culture and commerce still depends on PARC's inventions. Technology companies and many others in downstream industries have collectively realized trillions of dollars in revenue and tens of trillions in market value because of PARC's work. When PARC began its work in 1971, what most people thought of as a computer weighed more than a ton, needed to be cooled with water in a heavily air-conditioned room, took about 15 minutes to boot up, and was surrounded by a sort of priesthood of lab technicians in long white coats to cater to the needs of the machine. Data was entered with punch cards, and results were produced on clackety printers as words and numbers. There was maybe the occasional graph, but certainly no images, and the idea of video on a computer was positively silly. The Internet existed, but barely. While tens of billions of devices are connected these days, only 4 computers were tied together in the early days. Not 4 billion. Not 4 million, not 4,000, or even 400. 4. But Alan had developed a series of very different ideas as a graduate student in the 1960s, and they would lead to what he eventually called Dynabook, a battery-powered laptop with wireless access to a network that let you communicate with anyone and have access to all the world's information. Then he and the team at Xerox PARC invented that future. Alan didn't wait 30 years to say, "Wow, I sure have access to a lot of computing power now. What should I do with it?" He and his colleagues at Park envisioned a radically different educational tool that they could build around that power and use to provide a new kind of literacy and new meanings for reading and writing so children could discuss, play with, and learn powerful ideas. Then Allen and Park imagined all the pieces that would be needed. Some related to the computer itself, the kind of operating system that would tap into the new power, the windows that would let users flip easily between tasks, etc. Some related to supporting devices, in particular to capabilities for networking computers and for printing. Park then moved in a host of directions at once. The whole computing environment, not just the processor, gained momentum quickly. We're all better off as a result. Allen invented a future a second time, too. As an Apple Fellow, he helped pull together a vision for a so-called knowledge navigator, unveiled in a video in 1987. The device bears an eerie resemblance to the iPad, introduced 23 years later. While Steve Jobs obviously shaped the iPad in his own brilliant way, the vision in the Knowledge Navigator videos clearly guided research in Apple's labs for years before Jobs got involved. For good measure, Apple's work on the iPad gave the company the biggest gift in the history of business: the iPhone. According to Jobs, when he decided the iPad wasn't ready for production, he realized the technology could be packaged into something much smaller: a revolutionary phone. Et voila! Neither Apple nor the world has yet recovered. In the pre-iPhone world in 1996, Apple almost sold itself to Sun Microsystems for about $4 billion. As of this writing, Apple's market value is $2.34 trillion. The idea of inventing the future surfaced anew for the three of us as we tried to make sense of the dysfunction in the U.S. in recent years, on politics, race, the pandemic, and other public health issues, social media, and disinformation. As we write this in the summer of 2021, the Gulf of Mexico is on fire. A condo building just collapsed in South Florida and killed scores of people, and a town in Canada burst into flames and burned down as a heat dome repeatedly settled over much of North America. One of Paul's daughters sent him a panicked text. "There is no Planet B." One of Tim's sons told him, "You're worried about whether your Social Security benefits are going to be cut. We're worried about whether there's going to be a planet left by the time that's an issue for us." Chunka's daughter noted that he's often described as a futurist and once quipped to him, "Well, then you'd better not mess mine up." Can we reassure our kids, honestly? Or are we doomed to a dystopian future? There sure is a lot going wrong. As is our nature, we've settled on hope. We think we can envision a grand future, putting a stake in the ground for our kids and their kids, then draw on our decades of experience evaluating technology trends to start inventing what we're calling a future perfect. We're not saying we can predict the future. We very much abide by the oft-used line that it is difficult to make predictions, especially about the future. Besides, at their best, predictions represent the most likely outcome, and in pivotal times like today's, the most likely scenarios might well be ones that we want to avoid. No, rather than predict the future, we want to draw on what we've learned from Alan Kay. We want to invent it. More precisely, we want to help you invent it. Following the pattern Alan has laid out for us, we'll use this book to take you 30 years into the future and describe technological marvels that will be available to us all. These marvels are hard to envision today. While we can all get our heads around a twofold improvement in something, it's extraordinarily hard to imagine 3 decades of the sorts of twofold improvements in computing power every 18 months that Moore's Law was providing to Allen and his colleagues at Xerox PARC. How do you even process the idea of the million-fold increase in computing power over 30 years that they were designing into their work? So, we're going to try to do that imagining work for you and describe 7 so important as to be almost magical technological building blocks that will be available to all of us in 2050. We'll then paint some pictures of how those building blocks could be supplemented by other technological improvements and novel ideas that, together, will let us construct that future perfect. As amazing as these technological marvels will be, the building blocks are not the building. In fact, they could lead to an infinite number of buildings. So, we'll apply systems thinking as much as possible to consider how all factors interact and to point us toward a future that is optimized as broadly as possible, not optimized for each of its parts. As we'll explain more in the introduction to Part 2, too much planning has historically been done in silos, so we wind up with city streets optimized for traffic, for instance, but not for people. And we care much more about people than we do about cars. We all need to make this difficult mental effort. Ecosystems are really complex. Or we may waste the fabulous power these building blocks will provide us. We want you to get excited about the possibilities of these technological marvels, while also seeing the sort of work we all should be doing now to prepare for their possibilities. Technology will give us great gifts by 2050, no matter what we do. So we could let development happen on its own and then figure out how to react. But we think it would be much better to start planning for the implications, like experimenting now with how cities could be rethought based on driverless cars and some other technological wonders. Why wait 30 years to start learning when we can already see at least the outline of what's coming? To provide the groundwork for that planning, we'll not only describe the technological marvels, but we'll paint visions of 2050 based on what we call future histories. Short, provocative news articles set in 2050 that describe how key aspects of the world might look in areas such as transportation, healthcare, and the electric grid. We'll then provide you with tools you can use to envision and write your own future history for whatever part of the world you think is especially important and that you could help invent by 2050. Then we'll hand the keys over to you, encourage you to start right away on inventing your piece of the future, and wish you luck. So, yes, we're leaving the hard part to you. But we hope that, along the way, we'll have stretched your thinking a bunch and given you a powerful way to get started. If we all do our part, we can at least get close to that future perfect. If not, we may stumble our way into what we call the future pathetic. Think Brave New World or 1984. As we all see from what's happening around us today, technology can cut both ways. It can produce great gains, but dystopia is out there too. Let's harness the future rather than just taking our chances.